Smashed and broke. Yeah? Okay, so we're going to do them in the order. So we think this first one is magnesium sulfate, right? So what's the first thing we're going to always add? NaOH solution, okay. What are we expecting to see? White ppt, okay. Okay. So there it is, it's a white ppt. What is the white ppt? Name. Magnesium hydroxide. Okay, and in theory, nothing should change if I add extra, okay? There's extra, nothing's happening, okay? Alright, so I'll take my little beaker away, get a new one out, a new sample of unidentified solution A. We know what it is, but never mind. Okay, this time we're going to add...
No.
In order to eliminate which ion? The other one. Barium, yes. Okay. And as we expect, no precipitate with sulfuric acid because magnesium sulfate is soluble. Okay, if it was barium, it would give a precipitate because barium sulfate is insoluble, right? Yeah.
So should we mix them in order to find out whether precipitate forms or not?
In a test tube, yes you should, and I would recommend the method of holding it and flicking the bottom like that to mix them rather than shaking them like this. Okay? Alright, so we've identified the cation as magnesium. Okay, as far as the anion goes, we need a piece of red litmus. Okay, so I better put some of my solution back in here. Okay, I'm going to stick my red litmus in, like so. Okay, and still red, no change. All right, so that shows us that it's not. Stop. Make sure your brain's engaged in gear before opening mouth. We're testing for anions. Yes, it's not hydroxide and it's not carbonate, all right? Our next test is to add name barium nitrate. What do you expect to see? And of course we do, because that is a white precipitate of barium sulfate. All right? Okay, so that's the first one done successfully. We have shown it's magnesium sulfate. Of course we could have just looked at the label. Never mind. Okay, the next one is zinc sulfate, which in terms of an anion is going to be a similar test, but the cation is going to be a little different, isn't it? And hopefully it'll work fine. If it doesn't work fine, we're in deep trouble. Okay, first of all, sodium hydroxide, okay, and we get, okay, white precipitate in there. If I add in more, okay, just about redissolved, better confirm it, a bit more, there we go, redissolved. Redissolves because it forms a complex ion, yeah? Yep. 4 hydroxides around the zinc, okay? Alright, new sample, so now we know it's either zinc or aluminium or lead. Okay? Okay, so a new sample, and this time we're going to use ammonia, the other very useful solution. We expect to get a precipitate first up, and we do, alright, because again it's alkaline, so you get zinc hydroxide, right? When I add in more ammonia, okay, the precipitate redissolves. Now you can see I'm using quite large quantities here, so I had to put quite a bit in. You can do it much more carefully in your small test tubes on Friday. But if in doubt, if you don't feel you're getting the right result, repeat it, do it again, use more, okay? Okay, so that shows us that it's either zinc or... Oh no, it's only zinc, isn't it? Yeah. Yes, alright. Okay, so now we've got to do the litmus test again. We're doing anion now, right? Okay, so this is very repetitive, this one, isn't it? Because, once again...
No change.
Okay, no change, still red. Alright, and then we use our barium nitrate and we get, ta-da, our precipitate. Okay, so that shows us that the zinc was the cation and sulfate was the anion. Zinc sulfate, alright? And the third one is that of sodium iodide. Now, if you look at this bottle, it says potassium iodide. Will that make any difference?
No.
No, because potassium and sodium are interchangeable because they're always soluble, aren't they? Okay. So, identifying the cation. If I put some sodium hydroxide in, nothing happens, alright? Pretend I'm heating it, okay? Here's my moist litmus paper. Going near it, nothing's happening, okay, because I'm not doing the heating part on this, okay. So now we're looking for anion, okay, so without showing the ammonia form, we've shown it's sodium because it's not ammonium because it didn't produce any vapour that changed the litmus paper. Okay, so that's a kind of a what do you call it? Virtual experiment, there you go. Alright, so now we're looking for our anion, okay, so I put some more of our sodium iodide allegedly in here. Okay, first thing I'll do is put some litmus paper in. Okay, and okay, still pink, no change. So it's not hydroxide or carbonate, okay. So next thing is putting in barium. Alright, no change there, so it's not sulfate. Alright, so new sample. Okay, what do we put next? Silver nitrate. Okay, and here's my silver nitrate. And you can see the colour of the precipitate. You can see it better live than you can on the screen. Okay, it's not as yellow on the screen, but it's certainly yellow compared with the white ones we had up there before. Just to give you an idea of a colour match, there's a white one. Okay, you can see the difference in colour. Now, when we add ammonia to this, to confirm it's iodide, the precipitate should not dissolve. Because if it did dissolve, it would be chloride, yeah. So I'll put some ammonia in. Okay. You could say, well, you know, you could put more in. Blah, blah, blah. I can, but it's not going to change. Okay. So that precipitate is fixed. All right, silver iodide. All right, so we've shown that there was iodide and sodium, so it was sodium iodide. Questions? Okay, if you've got those sequences with them numbered, you're okay. You've got it sorted. All right.